Standard form of the quadratic equation is ax squared plus bx plus c equals 0. A, b, c are real numbers. A is not equal to 0. A is the coefficient of x squared, b is the coefficient of x, c is the constant term. Now, if ax squared plus bx plus c equals 0, then x is given by minus b plus or minus root of b squared minus 4ac whole divided by 2a. We have expressed x, the variable x, in terms of the constant terms a, b and c. This is called the quadratic formula. We use this formula to solve quadratic equations. Here are two values for x. X equals minus b plus root of b squared minus 4ac whole divided by 2a, or x equals minus b minus root of b squared minus 4ac whole divided by 2a. These two values are called the roots of ax squared plus bx plus c equals 0. This is the first value and the second value. These are called the roots of ax squared plus bx plus c equals 0. Let us take an example. Solve using formula x squared plus 5x plus 6 equals 0. Let us rewrite the equation as 1x squared plus 5x plus 6 equals 0. The coefficient of x squared is 1 here. Compare this with the standard form ax squared plus bx plus c equals 0. A is 1, b is 5, c is 6. Let us write down the formula. X equals minus b plus or minus root of b squared minus 4ac whole divided by 2a. Now it is time to substitute the values. First, minus b. B is 5 here, plus or minus root of b square. B is 5 and its square minus 4ac. A is 1 and c is 6 whole divided by 2a. A is 1. Now let us simplify. X equals minus 5 plus or minus root of 5 squared is 25 minus 4 ones are 4, 4 6 are 24 divided by 2 ones are 2. Let us simplify this further. Minus 5 plus or minus root 1 divided by 2. X equals minus 5 plus or minus 1. Root of 1 is 1 whole divided by 2. Let us separate the two values of x here. This is the first value, minus 5 plus 1 divided by 2, or x equals minus 5 minus 1 divided by 2. Let us simplify these equations. X equals minus 4 divided by 2, or x equals minus 6 divided by 2. 2 2s are 4, 2 1s are 2, 2 3s are 6, 2 1s are 2. Therefore, x equals minus 2 or x equals minus 3. The roots of the given equation are minus 2 and then minus 3. This is quite simple, isn't it? Let us take one more example. Solve using formula x squared minus 5x plus 6 equals 0. Let us rewrite the equation as 1x squared plus of minus 5 into x plus 6 equals 0. Compare this with the standard form ax squared plus bx plus c equals 0. A is 1, b is minus 5, c is 6. Write down the formula. Minus b plus or minus root of b squared minus 4ac whole divided by 2a. Care must be taken while substituting the values. x equals minus b. b is minus 5 here. Therefore, it will be minus of minus 5 plus or minus root of b square. b is again minus 5 whole square minus 4ac. a is 1 and c is 6 whole divided by 2a. a is 1. Let us simplify this. X equals minus of minus is plus 5 plus or minus root of minus 5 whole squared is plus 25 minus 24 whole divided by 2. X equals plus 5 plus or minus root of 1 divided by 2. Root of 1 is 1. X equals 5 plus or minus 1 whole divided by 2. Here are two values for x. Let us separate them. This is the other value. Now let us simplify. 5 plus 1 is 6. Then 5 minus 1 is 4. 2 1s are 2 3s are 2 1s are 2 2s are. X equals 3 or x equals 2. Roots of the given equation are 3 and 2. This method is very easy, but you should be careful while writing the coefficients and then substituting the values. Let us take one more example. Solve using formula 2y squared plus y minus 6 equals 0. Let us rewrite this as 2y squared plus 1y plus minus 6 equals 0. Compare this with the standard form. Ax squared plus bx plus c equals 0. A is 2, b is 1, c is minus 6. Write down the formula. Minus b plus or minus root of b squared minus 4ac whole divided by 2a. Now, you should write y here because the variable in this equation is y. Don't write x. Y equals minus b. b is 1 plus or minus root of b squared 1 square minus 4ac. a is 2 and c is minus 6 whole divided by 2a. a is 2. Now let us simplify this. Minus 1 plus or minus root of 1 squared is 1. Then minus times minus, minus multiplied by minus is plus. Therefore 4 2s are 8, 8 6 are 48. Y equals minus 1 plus or minus root 49 divided by 4. Y equals minus 1 plus or minus 7 divided by 4. These are the two values of y. Let us simplify them. Y equals plus 6 divided by 4 or y equals minus 8 divided by 4. 2 2s are 4, 2 3s are 6. 4 1s are 4, 4 2s are 8. Y equals 3 by 2 or y equals minus 2. Therefore, the roots are 3 by 2 and minus 2. Let us take one more example. 3m squared minus m minus 2 equals 0. Let us rewrite the equation as 3m squared plus minus 1 into m plus minus 2 equals 0. Now compare this with the standard form. Ax squared plus bx plus c equals 0. A is 3, b is minus 1, c is minus 2. Formula is x equals minus b plus or minus root of b squared minus 4ac divided by 2a. Now m equals, the variable here is m. Care should be taken to write down the correct variable. Don't write x. Minus b. b is minus 1 plus or minus root of b square minus 1 whole square minus 4ac. A is 3 and c is minus 2 divided by 2a. A is 3. Now it is time to simplify this. 1 plus or minus root of minus 1 whole square. Minus 1 into minus 1 is plus 1. Then minus into minus is plus. 4 3s are 12. 12 2s are 24. M equals 1 plus or minus root of 25 divided by 6. 25 is a perfect square. Its square root is 5. Now let us separate the two values. This is the other value. Let us simplify. M equals 6 by 6 or M equals minus 4 by 6. 6 1s are 6 1s are. 2 3s are 6. 2 2s are 4. Therefore, M equals 1 or M equals minus 2 by 3. The roots are 1 and minus 2 by 3. Consider one more example. 5n square minus 17n equals 6. We must arrange all the terms on left hand side in the descending order of powers of the variable. The variable here is n. 5n squared minus 17n equals 6. Bring 6 to the left hand side. It becomes negative. Let us rewrite the equation as 5n squared plus minus 17n plus minus 6 equals 0. Here a is 5, b is minus 17, c is minus 6. The quadratic formula is x equals minus b plus or minus root of b square minus 4ac whole divided by 2a. N equals, here the variable is n. Let us substitute the values. Minus b. B is minus 17 plus or minus root of b square. B is again minus 17 whole square minus 4ac. A is 5 and c is minus 6 whole divided by 2a. A is 5. Let us simplify this. Minus of minus is plus, plus 17 plus or minus root of minus 17 whole square is plus 289 minus into minus plus 4 5s are 20, 26 are 120. Therefore, plus 120. N equals 17 plus plus or minus root of 409 divided by 10. 409 is not a perfect square. Therefore, this cannot be reduced further. The two values of n are 17 plus root of 409 divided by 10 or 17 minus root of 409 divided by 10. The roots of the given equation are 17 plus root of 409 divided by 10 and 17 minus root of 409 divided by 10. Now, henceforth, we shall skip some of the steps. In the coming examples, we shall skip some of the steps. We have already understood how to identify the coefficients and how to substitute them in the quadratic formula. Let us consider example 6. 4x squared plus 4 root 3x plus 3 equals 0. A equals 4, B equals 4 root 3, C equals 3. Write down the quadratic formula, then substitute the values. X equals minus 4 root 3 plus or minus root of 4 root 3 whole square. 4 fours are 16. Root 3 into root 3 is 3. 16 multiplied by 3 is 48. And in the second term, 4 fours are 16. 16 threes are 48. Therefore, minus 4 root 3 plus or minus root 0 divided by 8. X equals minus 4 root 3 plus or minus 0 divided by 8. 0 when added to or subtracted from any number, the number remains the same. The number becomes unchanged. Therefore, x equals minus 4 root 3 divided by 8. 4 ones are 4 twos are. X equals minus root 3 divided by 2. The roots are minus root 3 divided by 2 and minus root 3 divided by 2. That is, the roots of the equation are equal. The equation has equal roots, or we can say that the equation has only one root. Consider example 7. Solve using formula x minus 1 over x equals 3, where x is not equal to 0. First, we need to bring the equation into standard form. X minus 1 over x equals 3. Here, we need to get rid of the denominator x. For that, we shall multiply the entire equation by x. X into x minus 1 over x into x equals 3 into x. X and x get cancelled. X squared minus 1 equals 3x. Let us bring 3x to the left hand side. X squared minus 3x minus 1 equals 0. Let us rewrite the equation. 1x squared plus minus 3 into x plus minus 1 equals 0. A is 1, B is minus 3, C is minus 1. Here is the quadratic formula. Let us substitute the values. Minus of minus 3 plus or minus root of minus 3 whole squared minus 4 into 1 into minus 1 whole divided by 2 into 1. X equals 3 plus or minus root 13 whole divided by 2. The two values of x are x equals 3 plus root 13 divided by 2 or x equals 3 minus root 13 divided by 2. 13 is not a perfect square. Therefore, we cannot reduce this further. Therefore, the roots of the given equation are 3 plus root 13 divided by 2 and 3 minus root 13 divided by 2. Let us consider one more example. Solve using formula 1 over x plus 4 minus 1 over x minus 7 equals 11 over 30. X not equal to minus 4, x not equal to 7. We need to get rid of the denominators here. There are 3 denominators. Easy way out is multiply the entire equation by the LCM of the denominators. LCM of the denominators is given by 30 into x plus 4 into x minus 7. Multiply the whole equation by 30 into x plus 4 into x minus 7, like this. First term multiplied by the LCM, second term multiplied by the LCM, and on the right hand side 11 by 30 times the LCM. X plus 4 and x plus 4 get cancelled. X minus 7 and x minus 7 get cancelled. 30 and 30, they vanish. Now what remains? 30 into x minus 7 minus 30 into x plus 4 equals 11 into x plus 4 into x minus 7. Let us open the brackets. 30x minus 210 minus 30x minus 120 equals 11 into x squared minus 7x plus 4x minus 28 plus 30x minus 30x, they vanish, minus 210 minus 120, they are the like terms. Again minus 7x plus 4x, they are also like terms. On the left hand side we have minus 330 equals 11 into x square minus 7x plus 4x is minus 3x minus 28. Let us open the brackets on the right hand side. 11x square minus 33x minus 308. Bring minus 330 to the right hand side. It becomes positive. 0 equals 11x squared minus 33x minus 308 plus 330. We get plus 22. 11 is a common factor here. 11 3s are, 11 2s are. We get x squared minus 3x plus 2. Let us swap the sides like this. X squared minus 3x plus 2 equals 0. Now we need to solve this equation using the formula. Let us rewrite the equation as 1x squared plus minus 3 into x plus 2. A is 1, b is minus 3, c is 2. Here is the quadratic formula. Let us substitute the values. Minus of minus 3 plus or minus root of minus 3 whole square minus 4 into 1 into 2 whole divided by 2 into 1. X equals plus 3 plus or minus root of 9 minus 8 divided by 2 plus 3 plus or minus root 1 divided by 2. X equals 3 plus or minus 1 divided by 2. Let us separate the two values of x. 3 plus 1 divided by 2, 3 minus 1 divided by 2. Let us simplify. 4 divided by 2 or 2 divided by 2. 2 ones are, 2 twos are, 2 ones are, 2 ones are. X equals 2 or x equals 1. Therefore, roots of the given equation are 2 and 1. Here is one more example. Solve using formula. 5x squared minus 6x minus 2 equals 0. We can rewrite the equation as 5x squared plus minus 6 into x plus minus 2 equals 0. A equals 5, b equals minus 6, c equals minus 2. The quadratic formula is given by minus b plus or minus root of b squared minus 4ac whole divided by 2a. Let us substitute the values and then simplify. Simplifying, we get plus 6 plus or minus root 36 plus 40 divided by 10. Now 36 plus 40 is 76. Root 76 can be simplified as root 4 into 19, that is root 4 into root 19, 2 into root 19, that is equal to 2 root 19. X equals 6 plus or minus 2 root 19 whole divided by 10. Now the numerator and the denominator have 2 as the common factor. 2 5s are, 2 3s are, 2 1s are. X equals 3 plus or minus root 19 whole over 5 Let us separate the two values. Now, the roots of the given equation are 3 plus root 19 divided by 5 and 3 minus root 19 divided by 5. Example 10. Solve using formula. Here, rewriting the equation as 1x squared plus 4x plus 5 equals 0. A is 1, B is 4, C is 5. Here is the quadratic formula. Let us substitute the values. Minus 4 root of 16 minus 20 whole divided by 2. X equals minus 4 plus or minus root minus 4 divided by 2. What is the value of root minus 4? A negative real number does not have real square root. Root minus 4 has no real values at all. Therefore, the given equation does not have real roots. Consider one more last example. Solve using formula. 1 over 2x minus 3 plus 1 over x minus 5 equals 1. Here again, we need to get rid of the denominators. LCM of the denominators is 2x minus 3 into x minus 5. Let us multiply the entire equation by the LCM like this. 1 over 2x minus 3 into 2x minus 3 into x minus 5 plus the second term into the LCM equals 1 into the LCM. 2x minus 3 get cancelled. X minus 5 and x minus 5 they get cancelled. What do we get here? X minus 5 plus 2x minus 3 equals 2x minus 3 into x minus 5. Let us open the brackets. Now x plus 2x, these are the like terms. Adding them up, we get 3x. Minus 5 minus 3 is minus 8 equals 2x squared minus 10x minus 3x. They are also like terms. Their algebraic sum is minus 13x plus 15. Let us bring 3x minus 8 to the right hand side like this. This becomes negative. This becomes positive. We get 0 equals 2x squared minus 13x minus 3x plus 15 plus 8. These are the like terms. Again, these two are also like terms. Let us simplify further. 0 equals 2x squared minus 13x minus 3x. The algebraic sum is minus 16x plus 15 plus 8 plus 23. Let us swap the sides. Now, rewrite the equation as 2x squared plus minus 16x plus 23 equals 0. A is 2, B is minus 16, C is 23. Let us write down the quadratic formula quickly. Let us substitute the values like this. We get plus 16 plus or minus root 256 minus 184 whole divided by 4. 16 plus or minus root 72 divided by 4. Root 72 can be simplified as root 36 into 2, that is root 36 into root 2 equals 6 root 2. 16 plus or minus 6 root 2 whole divided by 4. Here 2 is a common factor for both numerator and the denominator. 2 2s are 4, 2 8s are 2 3s are. Note that we need to divide both the terms in the numerator by 2. X equals 8 plus or minus 3 root 2 whole divided by 2. Let us separate the two values of x here. The roots of the given equation are 8 plus 3 root 2 whole divided by 2 and 8 minus 3 root 2 whole divided by 2. I will come to you with a new topic in the next session. Till then, bye.